All right, hello everyone. Welcome to EECS 494 discussion number 2 for the winter 2021 semester. This week will so last week we talked about blend trees and how they can help you with animation. This week is going to be a little bit more like lecture review. I got a lot of people asking questions about the observer pattern, which is something that is a technical topic that we covered at lecture on Wednesday. And it seemed a little bit unclear to some people. So today we're going to spend some time going over another example of using the observer pattern and how it can be useful. And then after that, after we go over that example, I'm going to show you a couple tips and tricks for Unity that might make parts of development easier in the future. So we're going to start off by sort of implementing the observer pattern in a certain way in our game. So let's get started. So I have the same project that we worked in last week. As a reminder, we have this character that can move left and right, and then it has an idle animation like this. It's not really important. That's just what the character is. But since last week, I've made one addition. I added a collider and rigid body onto the player. That's because we're gonna add some other stuff to the game, and we're gonna need a rigid body and capsule collider on our player to do that. I'm also going to increase the move speed of the player because I feel like the player is moving pretty slow. Let's increase it to 5. Okay, that's a little bit fast. So let's set it to 3 maybe. Okay, sounds good. Okay, so let's add some. I want to add some collectibles into the game, and we're gonna show you how sort of you can, like in this example, we'll add a collectible into the game, and then we'll use the observer pattern to create an event representing the collection of that collectible, and have different parts of the game subscribe to that event. So let's have a sprite here. Let's set this to 0.2, 0.2, 0.2. It's a little thinking emoji face. We'll give it a circle collider like this. And then we're gonna give it a tag here. We're gonna tag it with thunk because it's a face that looks like it's almost thinking, it's thunking. So we'll add our thunk here, and this is our object that we'll be using for our collectible. I like this, so I'm actually going to go ahead and make a prefab out of it. That way we can add a lot of them into our game, like maybe a couple over here. And then what I want to do is with each of the different ones, I want to make it maybe slightly bigger. Like this one, I'm going to make 0.3. Why don't we make this one huge? We'll make it 0.5. So we'll add all sorts of different sizes. But the last thing we want to do on this prefab is we want to make it a trigger, because it's a collectible, and we don't, as we remember, we want it to just kind of not have a collision, but when we collide with it, we just want to be able to collect it. So now that we've done that, let's go to our player script, player controller right here. I'll open it up in the Visual Studio Code, and we're going to add the onTriggerEnter2D function because we're using 2D colliders and 2D triggers. You can see this is a capsule collider 2D, rigid body 2D, and our collectible has a circle collider 2D. So we're going to be using the onTriggerEnter2D function. So what we're going to do is if other.gameObject.compareTag thunk. And this will return true if the other game object we collided with has the tag thunk on it, which is correct. It's true for all of our collectibles. So we're going to use that. And if that's the case, I have a score here. We'll initialize score to 0 in the beginning. And then here we'll say score plus equals 1. And we'll say destroy other.gameObject. And we're gonna destroy the thing that we collected. So We've written a little bit of code. Let's make sure our collectibles work now. Okay, so when we collected it, it went away. When we collected this one, it also went away. And finally, when we collected this one, it went away. So looks like we added our collectible in, all okay. Not too bad so far. We're doing a good job. So now we're going to add a UI because we want to tell the player how many thonks they've collected. So we're going to go to UI. We're going to add some text. I'm going to choose TextMeshPro. So you might have noticed that when you add UI elements, you have option between text and TextMeshPro, and with buttons and drop downs and input fields, you also have normal versus TextMeshPro, and you might be wondering what the difference is. TextMeshPro is like a special font system that makes your fonts not as blurry. It makes it what do you say? It's essentially, when you can use TextMeshPro, I would recommend using it because it's just overall better than the default text system and has a lot less issues with various screen sizes and all of that. So let me let's find this. Let's move it to the top left corner like this, our text. And we're going to give it an offset of maybe 20 and -20, like that. And why don't we make this say score? And we're gonna, let's name this score text. And finally, or we'll say thonks instead of score. How many thonks did you collect? And now we're gonna add a script. We're gonna call this score text. We'll make that the name of our script. So what our score text script will want to do, it's going to want to, let me move it into the scripts folder here. It's going to want to subscribe to an event that the player controller has. And then when that event happens, the score text is going to want to update itself when we get that. So let's make our delegate type. We're going to make public delegate void. Void means we want our event to not return any values. Thonk collection. And then what are we going to do? We're going to take in int score, like that. And now our player controller is going to have a public thonk collect on thonk collected. And then, like we did in lecture, we're going to check if on thonk collected is not equal to null. Then we're going to call on thonk collected with our new score value, like this. Now that we have that done, let's go to our score text, and then we're going to say, well, we need to get our player controller. So why don't we add a reference? Actually, let's go over the singleton pattern. Since we're only going to ever have one player, it might make sense to turn our player into a singleton. As a reminder, if you don't remember the singleton code, you can find it in the EECS494 GitHub repo. I believe it should be here in components. Let me check here. It might not be here. It might be in a different one. We can search this repo. Instance. Oh, yep. The Toast Manager example code, for example, is a good example of the instance. So if you ever need a reference on how the singleton pattern works, you can do that. So let's do it here though. We're gonna make our instance public though. Static player controller instance, and then we're gonna say at the beginning, if instance is not equal to null and instance is not equal to this, we're going to destroy this .game object, else instance equals this. And we're going to do don't destroy unload this .game object. So we added that, and we have our static instance now. So now we can go here, and we'll go to player controller .instance what did we call it? Enthunk collected plus equals. Well, we need a function, so we'll make a function void update score text int new score. And when this happens, we're going to update the score in our UI. If we come back here, our score text, it has a TextMeshPro object. So we're going to have to import using TMPro. And then we're going to need a public tmpro.textmeshpro. Wait, hold on. What is this? .tmp text. That's right. Score text. And then here we'll set score text is going to be equal to, we're going to update the text in the score, and this is the function we want to use here. So this plus equals syntax is kind of the confusing part here. This is a variable in our player controller representing a set of functions. And it can have one function, it can have no functions, it can have a million functions in it. And you can add functions to this list of functions by using plus equals. And you can remove functions from it actually by using minus equals. So like, let's say we added the onDestroy function, which runs when a component is destroyed. Some people think it's a good practice to, when you get destroyed, unsubscribe yourself from this event. That way you prevent any problems from occurring. But in our case, we're not going to be destroying anything, so we're not going to worry about that. So now that we've done this, we've written a lot of code. Let's make sure everything's going to work. Let's drag this and bring it in here, which we need to do. And then let's take our player. Our player is doing okay. And let's see what happens. Console. Null reference exception. Object reference not set to instance of an object. Let's see what error we caused. It's on line 12. So it says player controller. Oh, so the player controller is null. The player might not have been created yet. So we can actually solve this problem by going to project settings. We can go to script execution order. And we can add our player controller. We can actually bring it up here and make it run before score text. So the script execution order page in the project settings is actually it's a useful little place that if you need to set an ordering of something needs to run before something else, you can set that ordering here. So now once we've added that ordering, now we should be okay. And as we collect things, the event gets emitted and the UI subscribes to the event, just like we expect it to. And so that's sort of the example I wanted to show you here of using it. And as a reminder, any number of things can subscribe to this event. So why don't we make another thing that subscribes to this event for us? For an example here, I added another sprite in before. It's this dinosaur, the Yi dinosaur. If you've seen that meme of the dinosaur going Yi, you might recognize this. So what I'm gonna do is I'm gonna add a Yi controller script for our Yi. Actually, no, we're gonna do this differently. We're gonna add an empty game object called Manager. So what to iterate or explain what I'm gonna do here as a idea. I'm just coming up with something on the fly here. We're going to, every time we collect a thinking emoji, we're going to spawn a dinosaur face. So this will have our Yi script on it. And our Yi will look like this. And why don't we add an audio to it? I have the sound for the audio here, and I have it set to play on awake. So that means the moment that the object gets spawned, it'll play the sound effect. If you're watching in Discord, you actually might not hear that. I don't think Discord is sharing my audio, but it plays a sound effect essentially. So what I'm going to do is I'm going to make a prefab out of this. And now I'm going to, in our script that we make here, we'll, what do we want? Well, we want a public game object Yi prefab, because we're going to be spawning a prefab every time the event occurs. And we're going to have to make our event void on thunk scored int new score. And even though we might not need to know the new score here on this event, because the type of the delegate has an int parameter, we are required to have a function that takes in an int as the parameter. Otherwise, we're not able to subscribe to the event. So player controller dot instance dot onthunk collected plus equals onthunk scored. So we're gonna make we don't need an update function. So whenever we score something, we're gonna do game object dot instantiate Yi prefab, and then this will return a game object. So game object new Yi is going to be set equal to this, and then let's set its location. Let's look at the possible locations here. If I move the player, the leftmost x is 9 and positive 9, and the y value is 4 to negative 4 about. So float x is equal to random dot. Hold on, let me. I believe Unity has random dot range is what we want. Yeah, random dot range between -9 and 9, and then float y equals random dot range -4 and 4. And we want these to be floats because we're calling it with floats. And then new Yi dot transform dot position dot x equals x. New Yi dot transform dot position dot y equals y. We might need to set it equal to a new vector 3 with x, y, and 0. Let's do it like that. And now let's see if this works. So now our goal is that every time we collect a thinking emoji, we'll also get a Yi game object. Let's remove this one. And then let's make sure this has the prefab here. And then in the prefab, I'm going to set the volume down to very low so that it's not too annoying. We're going to go here. Oh, cool. Awesome. Looks great. We got this to happen. So now let's say we wanted to update this so that, you know, well, we noticed that we kind of have useless data here, where we're not really using the value of new score. And there's a couple ways that we could deal with that. We can either add multiple different event types that get called, one with the parameter, one without the parameter, so that we're not passing unnecessary data. The other thing we could do is just, find a reason to use it. Why don't we use it? So dot transform dot scale. Local scale should be a vector3, or vector3 dot 1 times new score. So how about we'll increase the size of the dinosaur we make depending on how many thinking emojis we collect, because why not? Now it's even bigger. Incredible. So that's sort of the example I wanted to go through of using the observer pattern, making multiple things subscribe to the observer, using the observer pattern to an event. We also, in the process, we reviewed the singleton pattern for creating for game objects that there's only going to be one instance in your game. And what else did we go over? We went over how to sort of create game objects. We created prefabs. We used a little bit of audio. So we talked about UI in TextMeshPro. So we went over a couple of different things during this example that hopefully will help you as you continue here on project 1. So that's what I wanted to show you in terms of this worked example today. But before we go, I wanted to talk about a couple interesting tips that you might not be aware of when it comes to Unity, involving the inspector and finally coding. So the first thing involving the inspector, you may not know that these number fields, they support arithmetic in them. So that is to say, let's say I think 3 is a little bit slow, and I want to go a little bit faster. So I can say 3 plus 1, and it's going to set it to 4. Is our speed? Our speed is a float. So I can even say 4, and then, I try that out. I'm like, oh, 4 is too fast. So let's go minus 0.5. And that'll automatically do the math in the inspector and submit that value in here. I can even do times 2 if I want to go twice as fast. And I can divide by, things like that. And I can do arithmetic in inspector fields here, which is actually, it can be useful when you're on the fly and you just want to incrementally increase something by a certain value and you don't really want to do the math for it. So like, let's say I wanted to multiply by 1.2. I can, times 1.2, or, times 5.4. And I can multiply by all these random values and get going there. The other thing I wanted to show you in relation to the inspector is you can turn your public number values that are ints or floats into sliders in your code. And the way you do that is using there's this feature in C#, I forget what it's called, I think attributes. But basically, above your public variable that you have in the inspector, you're going to use square brackets, and you're going to say range, and then we're going to say min and max. Let's say the minimum speed is 2, and the maximum speed is 10, like that. And since we put that in the line directly above our public variable for move speed, when we come back in the Unity inspector, this has now become a slider for us. Instead of having to enter a value directly, now we can experiment around with sliding. So I can say, okay, how about this? Oh, that's too fast. Let's slide it down. And now we added our own slider in rather than having to use number values too. We can use this if you want, which is pretty cool. The last thing I wanted to show you related to Unity, the little tip, is the assert classes. So something that you might remember from EECS 280 and EECS 281 in C++ is assert statements, which you can use to check if things are true or false. And if an assert statement fails, your code will crash. Unity has its own assert class where you can assert if things are approximately equal. And approximately equal is used to compare two floats. Equal is used to compare like integers and booleans. You have is false and is true. And you have all these assert statements that you can make in your code. And what's really great about them is that assert statements will only happen. They'll only run in the inspector and in development builds. They won't appear in release builds that you might prepare for submitting to Canvas or, releasing to the public to play. So they're actually really great while you're working if you're experimenting around with numbers, experimenting around with the balance of your game, but you still want certain things to be true. You can add assert statements into, your update functions, into your little events, things like that. Just like sanity checks, like you might have done in EECS 280 and 281. And they actually can save you from submitting potentially buggy code. It's just an additional extra check that you can add in before you submit to make sure that you don't submit something buggy and then end up losing points for it. Yeah, so that was the third and final tip I sort of wanted to tell you about with Unity. Those are sorts of all. That's all of that I had prepared for today. That review and these tips. Next week, discussion will be about the P1 Gold, the portfolio component. So one of the parts of the P1 Gold assignment is that you create a sort of portfolio website for yourself and post your final P1 build to that portfolio site. And I'll be in next week's discussion showing you how to complete that part of the assignment if you don't really have any experience with web development. And hopefully that'll be fun. Are there any questions I can take from our live attendees? If not, that's all I have. Have a good weekend, everyone. All the best with P1 Alpha. And as always, let us know if you have any questions. We're happy to help.